What specific problem does the new method or algorithm aim to solve regarding data contamination in large language models?
The new method aims to address the issue of search time contamination, STC, in large language models, LLMs, that occurs when these models access online search results during inference. Specifically, STC arises when LLMs retrieve both questions and their correct answers from publicly available datasets, such as those hosted on platforms like Hugging Face, leading to compromised evaluation integrity. The paper demonstrates that this contamination can significantly inflate accuracy metrics on capability benchmarks, as agents may rely on retrieved ground truth labels instead of their own reasoning. To mitigate STC, the authors propose best practices, including the implementation of multiple search filters, internal auditing systems, and transparency in reporting evaluation setups. These recommendations aim to enhance the trustworthiness of evaluations and prevent the leakage of test data into the model's context during the search process.
Can you illustrate step-by-step how the proposed method identifies and mitigates search time contamination, STC, in search-based LLM agents?
The proposed method identifies and mitigates search time contamination, STC, in search-based LLM agents through a systematic approach. First, it employs a contamination check using substring matching to identify instances where retrieved sources from platforms like Hugging Face contain exact questions and answers from the evaluation datasets. Second, the method conducts ablation experiments by applying various search filters, such as blocking Hugging Face domains, to isolate the effects of STC on agent performance. Third, it implements a multi-stage filtering model, which includes keyword filtering to exclude irrelevant sources and substring matching to detect exact matches from evaluation datasets. Finally, the method emphasizes transparency in reporting by recommending detailed documentation of the evaluation setup, including filter implementations and STC auditing processes, to enhance trustworthiness and facilitate community-driven detection of STC.
Can you provide a simple yet illustrative example demonstrating the inner workings of your proposed algorithm to measure STC?
To measure search time contamination, STC, we implemented a straightforward algorithm that checks for contamination by logging all retrieved sources during the evaluation of search-based LLM agents. For instance, if an agent retrieves a source from Hugging Face that contains both a question and its corresponding answer from a benchmark, we mark this instance as contaminated. Specifically, we utilize substring matching to identify if any retrieved source matches the benchmark items, which allows us to quantify the prevalence of STC across different datasets. In our experiments, we found that approximately 3% of samples in the Humanities Last Exam HLE benchmark were contaminated, demonstrating the effectiveness of our algorithm in detecting STC. This method not only highlights the contamination rates, but also informs the development of best practices to mitigate STC in future evaluations.
What theoretical or practical benefits does your approach offer in comparison to existing evaluation methods for LLMs?
Our approach offers significant theoretical and practical benefits over existing evaluation methods for LLMs by addressing the issue of search time contamination, STC, which can compromise the integrity of benchmark evaluations. By demonstrating that LLMs can inadvertently access and utilize test data during inference, we highlight the need for tailored benchmarks that prioritize information-seeking capabilities, such as BrowseComp and Mind2Web, rather than conventional knowledge benchmarks. Additionally, we propose a set of best practices, including multi-stage filtering and internal auditing, to proactively prevent STC and enhance the trustworthiness of evaluations. Our findings emphasize the importance of transparency in reporting evaluation setups and mitigation strategies, which can foster community-driven detection of STC. Ultimately, our work aims to ensure that LLM evaluations reflect true capabilities in real-world scenarios, thereby improving the reliability of performance claims.
How did you validate or test your method, and what specific datasets and benchmarks did you use to corroborate your findings about STC?
To validate our method and test for search time contamination, STC, we conducted experiments using 3 capability benchmarks: Humanities Last Exam, HLE, Simple QA, and GPQA. We evaluated search-based LLM agents, specifically Sonar Pro, Sonar Reasoning Pro, and Sonar Deep Research, under their default configurations to measure the prevalence of STC. Our findings indicated that approximately 3% of HLE samples showed contamination, with accuracy differences of over 10% for Sonar Pro and 20% for Sonar Deep Research between contaminated and uncontaminated samples. Additionally, we performed ablation experiments by blocking Hugging Face as a source, which significantly reduced accuracy on contaminated questions, confirming that Hugging Face contamination affects outcomes. This comprehensive approach allowed us to estimate the contribution of search and specific sources to the overall performance of the agents, thereby corroborating our findings on STC.
What limitations did you encounter with the proposed method, and what future work do you suggest to address these challenges?
The primary limitation encountered with the proposed method is that the hard-coded URL detector only identifies a narrow range of Hugging Face sources, failing to capture the full extent of search time contamination, STC, from other potential sources. This limitation suggests that the current approach may not adequately address the broader issue of contamination, as many datasets can be hosted elsewhere or re-uploaded by third parties. To address these challenges, future work should focus on developing browser agents capable of auditing all retrieved sources to detect deeper contamination. Additionally, exploring the situational awareness of models during evaluations could provide insights into their behavior regarding STC, including whether they intentionally seek out contaminated sources. Lastly, efforts to request takedowns or gating of third-party uploads on platforms like Hugging Face could help preserve benchmark integrity and improve the reproducibility of results.